Alright, this is Ken Roosevelt, and we're going to talk about probability of intersection or union word problems. Here's an example word problem. WLD Incorporated, a national data collection agency, estimates that 37% of all customers at home warehouse stores in the U.S. own their own home. WLD also estimates that 35% of all home warehouse customers have lived at their current address for less than 5 years, and that 33% of all home warehouse customers both own their own home and have lived at their current address for less than 5 years. Using these estimates, what is the probability that a randomly selected home warehouse customer owns her own home and has lived at her current address for less than 5 years, or both? So what we need to do is we need to set up our Venn diagram. So I have my Venn diagram here, and it looks like they're saying 37% of all customers own their own home. So I'm going to go, this circle will be own home, and over here they say 35% have lived at their current address for 5 years. So this is 5 years at current address. I'll just put CA. Okay, now in this whole circle, the own home circle, there can only be 37%. In this CA circle, this 5 years at current address, there can only be 35%, but they have this little caveat that 33% of all home warehouse customers both own their own home and have lived in their current address for 5 years, for less than 5 years. So they give us the intersection here is 33%. So I'm going to fill that in. Let me grab a black pen. 33% goes there. Once I know that, I know everything in this circle over here has to add up to 37. So what more do I need? I need 4%. Okay? And in this circle over here, there can only be 35%. So what more do I need there? I need 2%. That's a big fat tip on that pen. I should use it more. Okay, so I got 4%, 33%, and 2%. So the union is 39%, which leaves outside 61% are neither. All right, using these estimates, what is the probability that a randomly selected home warehouse customer owns her home or has lived at her current address for less than 5 years, or both? So basically they're saying own homes. All right, I'll go let owning home equal set H. Okay, so this thing over here, I'm calling this H. And let current address 5 years at the current address, we'll call that we'll just call that C for current address. So let 5 years at CA equal A. So what they're asking me here is, what is the probability for H or A? They own their home or they live at their current address. So that's H or A. They're just looking for the union. What's the probability in the union? We add it up. It's 39. So the answer is P of that equals 0.39. And I can go back to Alex and I can type in 0.39. What is the probability? And we write it in as a decimal. And that's it. So you just have to discern what's what. All right, let's do more practice. All right, so our next problem is, at a certain fast food restaurant, 43% of the customers order a chicken sandwich, 37% of the customers order French fries, and 15% order both a chicken sandwich and French fries. So we always start with the 15% to fill in our Venn diagram. That goes in the center because it is in the intersection because both. All right, once we know that, we still have the 43 and the 37 to think about. So the 43 is in this whole chicken circle. Let me put a big C up here. I'll do it with this one. That's for chicken. This is for French fries. So there's another, 28% in here? Because 28 plus 15 is 43. So how did I get that? I did 43 minus 15. And then there's 37 in this whole circle, so there's another 22% in here. Now the question is, I'll use purple. Find the probability that a random selected customer will order a chicken sandwich or French fries. Or union. They want the probability of the union, so they want what is P of C union F. And the answer is, we have this formula. You can do P of C plus P of F minus P of C intersect F, and that would be 43 plus 37 minus 15, and that would give you your answer. Or since I filled in the Venn diagram, we could do 22 plus 28 is 50 plus 15 is 65, and that would be our answer, 65%. And let me go back here. I did it earlier and I had 12 where I should have had 22. There we go. There we go. That's it. So we have those two examples, and it's very easy using the formula or just filling in the Venn diagram. Adios. I think that in some circumstances, Alex will do what it just did in the last two problems, where it'll give you P of A, P of B, it'll give you the intersection, and it'll ask you to find the union. However, I don't think that's always the case. I think sometimes you'll be given this, and this, and be asked to find this in there, the intersection, rather than the union. But that's no more difficult, because you can still see in this equation I have 3 pieces out of 4. So if you have 3 pieces out of 4, you can solve for the one you're missing. So the manipulation of the formula is very simple. If you add P of A intersect B to both sides, and simultaneously subtract P of A union B from both sides, you get these guys cancel, those guys cancel, and you will be left with P of A plus P of B, because those haven't gone anywhere, minus P of A union B equals P of A intersect B. So to find the intersection, you do the same thing basically. You add up A and B and subtract out the union. Okay, it works either way. And that formula might come in handy if they give you one of those word problems. I thought of this after I made the video. I'm not going to go back into Alex and try to find one of those problems, but I think they are out there. So be on the lookout for that. But the process, funny enough, it's still the same. Okay, bye-bye.